let's take a look at ionic bonds. Okay? An ionic bond is just like any other bond. A bond is an attractive force that holds things together. Well, an ionic bond holds ions together. And here's what you got to keep in mind when you're doing anything with ionic bonds. Oppositely charged ions attract. Okay? Just like all opposite charges attract, oppositely charged ions attract. In fact, what we say is an ionic bond forms because an electron is transferred from one atom to another. Okay, so this forms when electrons are transferred. And what our job is to do is we've got to be able to predict how many electrons are going to be transferred between how many atoms, and from that we can come up with a formula. So I guess I'm going to say ionic bonds and formulas. Okay? And so this is not too difficult. Okay, you start with two elements. So if it's an ionic thing, it's always going to be involving metals and nonmetals. So this always forms when metals give electrons to nonmetals. And so here's what we're going to do. We're going to pick a metal and a nonmetal, and we're going to see if we can figure out how they're going to get together. So we need a periodic table. There it is. A metal. Here's calcium. Calcium's a metal. It's an A group metal. I can deal with it. It's got 2 valence electrons. Okay, and we'll pick a nonmetal, say chlorine. Chlorine's in group 7. It's got 1 valence electron. So we're going to get calcium and chlorine together and see what we can do. Okay, we always start with our electron dot diagrams. Calcium is a metal with 2 electrons, right? We can't put them together because no side gets 2 before all sides have 1. Calcium looks like that. Chlorine is a halogen. It has 7 valence electrons. Okay, so we've got to go from this. We're going to get charges. Okay, calcium has 2 extra electrons, right? They're trying to get to 8 or 0, so calcium will give those both away, and when it does that, its charge is 2 positive. It's got 2 extra protons compared to electrons because it lost 2 electrons. Chlorine has got 1 empty spot. Okay, so it'll fill that spot, and when it fills that spot, it'll have a total of 8 valence electrons. Whenever you draw ions, ions will always have 0 valence electrons or 8 valence electrons because they either lose them all or gain them all to fill up the outside energy level. Okay, it took 1 to do this, so this is a 1 minus ion. Now, that means this calcium actually transferred an electron here. Okay, but it's transfers away 2, so it had to do something with this. So our job is to figure out basically how can calcium transfer 2 ions or 2 electrons if chlorine's only going to take 1? Well, the answer is simple. It's going to be, well, it needs to transfer to more than 1 chlorine atom. Okay, and so since calcium has 2 electrons to give away, it needs 2 chlorine atoms to give them to. So this actually forms between 1 calcium ion and 2 chlorine ions, right? And so to do that, we denote a little 2 down here. That thing's called a subscript, and it just shows me how many things are actually bonding together to make this neutral, to make this compound neutral. So there's 1 calcium ion for every 2 chlorine ions. Okay? Now, you can add as many of these as you want, but the ratio is always going to stay the same. Calcium to chlorine will be 1 to 2 because that's the charge ratio, right? The charge of a calcium is 2 to the charge of a chlorine, which is negative 1. So we need twice as much chlorine as calcium to make everything neutral. Okay, so basically the rule to ionic compounds is ionic compounds are going to be neutral. Okay, and you have to figure out how much of each ion you need in order to get the thing neutral. So compounds will be neutral, and I'm pretty sure I just spelled that wrong. I won't tell anybody if you won't. Okay, so compounds are neutral, and if you can get from electron dot diagrams to charges, then the formula is pretty straightforward. Okay, because there's a neat little trick. So if we pick another couple elements, okay, another couple A group elements, like say aluminum, which is over here in group 3, and sulfur, which is in group 6. So we'll take aluminum and we'll get it together with sulfur. Okay, Aluminum is a group 3 element, so it's got 1, 2, 3 valence electrons. Sulfur is a group 6 element, so it's got 6 valence electrons. Okay, and from this we can see aluminum will give away 1, 2, 3 electrons, so aluminum is a 3 plus ion. Okay, sulfur will take 1, 2. So sulfur is going to fill up its empty spots, and it's going to have a total of 8, but now it's a 2 minus ion. Okay, these are oppositely charged ions, so they are going to attract, but aluminum's got to have enough places to give electrons to, and one sulfur atom isn't enough. Okay, but sulfur always wants 2, so we've got to keep in mind how are we going to get these things to be neutral. Okay, well, the easiest way is to say, well, what do 3 and 2 both divide? 3 and 2 both divide 6, and so I'm going to have aluminum, which is a 3 plus. How do I get to 6? Well, I need 2 of them. Sulfur, which is a 2 minus. How do I get to 6? I need 3 of them. Okay, but the easy way is to just say, oh, well, I can take these and cross them. Okay, and so the 2 that was with the sulfur goes with the aluminum. The 3 that was with the aluminum goes with the sulfur, and I end up with Al2S3. Okay, this is the formula for aluminum sulfide. Okay, and it shows the ratio. It shows me that it's going to take 2 aluminum atoms or ions for every 3 sulfur ions in order to get the charge to be neutral. Okay, now you can again add as many as you need to in a crystal of aluminum sulfide, but the ratio is always going to stay the same: 2 aluminum ions to every 3 sulfur ions in order to be a neutral compound. Okay, the last thing to do on this is to take a look at one that's a transition metal. Okay, and so copper comes in a couple varieties. There can be copper 1 or there can be copper 2, and so we'll just randomly pick copper 2 and we'll combine it with fluorine. Okay, and fluorine, which I just spelled wrong, is a halogen, and so I know it's got 7 valence electrons. Copper, okay, well, let's pull up the periodic table. Copper is right here in the middle. Okay, if you find the periodic table, copper's element 29, okay, it's a B group element. That's why I had to put the little Roman numeral after it. Fluorine is up here in the top. It's a 7. It's a halogen. It's got 7 valence electrons. Okay, so when I start with the electron dot diagrams over here, it's pretty easy. Copper is Cu, and it's got 2 valence electrons, and I know that because of that Roman numeral, 2 valence electrons. Fluorine is a halogen. It's got 7 valence electrons. Okay, so what I can look at and see is I can see copper, being a metal, has 2 electrons to give away, so it'll be a 2 plus ion. Fluorine, being a non-metal, has 1 open spot. Okay, so it'll fill that 1 open spot, and it'll be a 1 minus ion. So there's my copper and my fluorine ions. Okay, since copper's giving away 2 but fluorine's only taking 1 electron, we're going to need 2 fluorines for each copper. So we're going to write this CuF2. Okay, and then again, that shows me the ratio of my ions in the compound. Okay, the last thing to talk about is how to name it. Okay, and ionic compounds are really, really easy to name because the name is not very descriptive at all. Okay, all it says is what's in it. Okay, it doesn't say how many of them are in them. It doesn't say what the ratio is. It just says what's in a compound. And so if you can look at the formulas that we've had Al2S3, we've had CuF2, okay, and I think we had CaO2. Okay, all these are named almost identically the same way. The one exception is this copper. Okay, aluminum is aluminum. Okay, S is sulfur, but when it's in a compound, we don't write sulfur, we write sulfide. Okay, copper is still copper, but this was copper 2, so we have to keep that Roman numeral in our name. So that's copper 2 fluoride. And then the last one here is calcium. Maybe we did sodium, can't remember. Calcium oxide. Okay, and so the trick is change the ending to IDE and you're good. If it's got a Roman numeral in it, then you need the Roman numeral in the name. Now, the Roman numeral doesn't go in the formula, it just goes in the name. Okay, so naming an ionic compound, fairly straightforward. Figuring out an ionic compound should also be a fairly straightforward process.